India's Chandrayaan-3 mission is already revealing new insights about the moon's enigmatic South Pole. Future missions to this region are planned by the US, China, and Russia, so what makes it so fascinating? It's a place where no human-made object has trundled before. Last week, however, the diminutive Pragyan rover slid down a ramp from its mothership, India's Vikram lander, and began exploring the region around the moon's south pole. The uncrewed spacecraft is something of a pioneer, the first to make a soft landing in the frigid, crater-strewn lunar polar landscape. Whereas the Apollo missions of the 1960s and 70s primarily set down near the moon's equator, the lander from India's Chandrayaan-3 mission successfully touched down about 370 miles, 600 kilometers from the lunar South Pole, closer than any spacecraft has been to this location. It arrived hot on the heels of a failed Russian attempt 2 days earlier, the Luna 25 spacecraft, which span out of control and crashed. India's mission is the start of a rush of activity at this enigmatic part of the lunar surface that will ultimately see humans set foot there later this decade. It's just incredible that this is happening, says Simeon Barber, a planetary scientist at the Open University in the UK. Alongside India and Russia, both the US and China have their sights set on the moon's south pole. There they hope to investigate some of the moon's most intriguing mysteries and perhaps even exploit what they find. But what is it about the moon's south pole that has made it so attractive to these visitors? Already Chandrayaan-3 and its suitcase-sized rover have sent back a few tantalizing hints of the strange environment they find themselves in. Traveling at around 1 centimeter, 0.4 inches, every second across the dusty surface, the Pragyan rover has edged itself several meters away from its mothership. Burrowing its sensors into the lunar soil along the way, the rover has revealed a curiously sharp drop in temperature beneath the surface. At the surface, it measured a temperature of around 50 C, 120 F, but just 80 millimeters, 3 inches, below this, it fell to -10 C, 14 F, a temperature difference that has surprised scientists. Onboard chemical analysis equipment has also indicated the presence of sulfur, aluminium, calcium, iron, titanium, manganese, chromium, and oxygen in the lunar soil. Both of these early findings hint at why scientists are eager to explore the south polar region of the moon. The moon's shallow axis of rotation, 1.5 degrees, compared to Earth's 23.5 degrees, means some craters at its poles never see sunlight. Coupled with low temperatures in these locations, scientists believe this has resulted in an abundance of ice, much of it made of water that is either mixed into the soil or exposed on the surface. There are hopes that the ice could be used as both a resource for astronauts and a springboard for future scientific discoveries. It is a unique location, says Sumitra Mukherjee, a professor of geology at Jawaharlal Nehru University in New Delhi, India. The availability of water is very important. Sometimes dubbed craters of eternal darkness, permanently shadowed regions are angled in such a way that the sun's rays never reach their innards, meaning they have potentially stored ice for billions of years. Our best evidence for water ice on the moon comes from a NASA experiment in October 2009 when an empty rocket was purposefully slammed into a crater at the South Pole. The plume of material had evidence of water, says Margaret Landis, a planetary scientist at the University of Colorado Boulder in the US. That is our one direct observation of water ice on the moon. Other data points to a higher reflectance at the poles, a likely result of ice, while a higher amount of hydrogen at the poles has been observed, perhaps a result of water ice. Last year, scientist William Reich at NASA's Ames Research Center in California flew NASA's now retired SOFIA telescope in a plane to study the moon, finding evidence of hydrogen just outside the landing site, now occupied by Chandrayaan-3's Vikram and its rover since they touched down on the 23rd of August. These recent discoveries of water ice have spurred a renewed interest in exploring the moon, and in particular, its south pole. India's lander and rover will now allow scientists to test theories that lunar researchers have been proposing about water ice presence in the lunar soil, says Anshul Sharma, a former engineer at the Indian Space Research Organization, ISRO, now working at the University of Trento, Italy. While Chandrayaan-3's data will be useful, it is later missions that will land closer to the South Pole that scientists are particularly excited about. Here, there are craters known as permanently shadowed regions, PSRS, sometimes dubbed craters of eternal darkness. These are angled in such a way that the sun's rays never reach their innards, meaning they have potentially stored ice for billions of years. The South Pole has more craters than the North Pole, likely a random outcome of how many meteorite impacts have hit the surface, making the South Pole a more attractive target. Temperatures in PSRS might drop below -200°C, -390°F, making them prime locations to look for ice. A NASA rover set to head to the moon's south pole in late 2024, called Viper, will drive into some of these PSRS, switching on headlights to shed light, literally, on their secrets. The mission should tell us if there are blocky chunks of ice or little crystals mixed into a sandy mix, says Dan Andrews at NASA's Ames Research Center, Viper's project manager. Viper might not be the first mission to enter a PSR, however. A preceding mission, called the Micronova Hopper, from the U.S. firm Intuitive Machines, may be sent to the moon earlier in 2024. While it lacks the instrumentation of Viper, such as a drill to dig into the surface, it will use its thrusters to jump into a PSR at the moon's south pole, giving us our first ever glimpse inside. These are not the only missions targeting the moon's south pole, though. A follow-up Indian mission in partnership with Japan, Chandrayaan-4, will also head here, while China has signaled its intent to land in this region, and Russia has another planned South Pole mission. Water ice is driving that interest. If it does exist in abundance and is accessible, it could be a valuable resource both for human settlements on the moon and exploration farther into the solar system. If the ice can be stripped from the lunar soil, it could be split into hydrogen and oxygen, a key component of rocket fuel or a potential source of drinking water and oxygen for human settlements. The simplest way to mine it is to dig up the icy soil and put it in some kind of oven to sublimate the ice, says Kevin Cannon, an assistant professor in geology at the Colorado School of Mines in the U.S. We could put enough propellant into a depot for a rocket to refuel and reach the outer solar system many times over. There's also access to spots that are illuminated for up to 90% of the year, which gives good solar power for processing the soil into oxygen and metals like aluminium. These dreams of deep space travel and living on the moon are closer than one might think. In 2025, NASA plans to land humans on the surface of the moon on a SpaceX lander for the first time in half a century as part of its Artemis III mission. They will land at a currently unselected site at the South Pole and directly prospect for ice for the first time. The main objectives for that mission are learning how to land and operate in the polar regions, says Jacob Bleacher, NASA's chief exploration scientist. Depending on the nature of ice discovered by previous missions like Viper at the South Pole, the astronauts will likely carry tools to collect some and return it to Earth. Future Artemis missions may then look to utilize this more keenly as a resource. It is an iterative set of steps, says Bleacher. The prospect of other potentially usable minerals and metals on the moon's surface could also be mined and used by astronauts to construct the infrastructure they will need to survive there. There are many scientific reasons to explore the moon's south pole, too. Scientists are eager to solve the origin of the moon's water, which may have been erupted by ancient lunar volcanoes billions of years ago, delivered by asteroids or comets, or even carried on the solar wind. What's really exciting about water on the moon is really understanding how rocky planets get their water, which is a key part of their habitability, says Landis. Understanding how the moon got its water can tell us more about Earth and also rocky exoplanets in other solar systems. Additionally, China's Chang'e 4 rover has found evidence for a vast crater buried close to the south pole of the moon, resulting from a violent impact early in its life, which scientists are eager to learn more about. We can see a cross-section of the buried crater using radar, says Jianqing Feng at the Planetary Science Institute in Arizona. Brett Denevy, a planetary scientist at Johns Hopkins University Applied Physics Laboratory in Maryland, U.S., who was selected to lead a geology team to set scientific goals for the Artemis III astronauts. Earlier this month, also notes that terrain at the South Pole is some of the oldest on the moon, with less evidence of recent volcanism. That provides a fantastic opportunity to look at some of the really early solar system processes that aren't recorded on Earth, she says. Denevy's team is keen to solve other mysteries about the moon, such as why its far side has many more craters than the near side and the nature of a magma ocean that likely once covered its surface. We still have these really fundamental questions about the moon, she says. Chandrayaan-3 may be just the start in answering these questions, and perhaps even living and working on the moon like never before. We're going to the moon to learn how to survive in the solar system and build a blueprint for exploring space, says Bleacher. And we'll be able to learn about the history of the solar system. This really is a next big step for humankind.